Hi students, today we will discuss about Dubonier's law of triode and Newland law of octave, and this belongs to classification of element chapter. And today we will discuss about two main concepts, that is the Dubonier's law of triode along with that Newland law of octave. Before discussing about these two concepts, first of all we will discuss about what is the need to classify the element. What is the need? So already you know that now total 118 elements are there. Now when I go back to the discovery of the element, whenever in the year of 6061, Robert Boyle is give the definition of an element. Just he define an element as any substance that cannot be decomposed into further by any physical or chemical reactions. Element we are not further divided by physical or the chemical reaction. That the definition is given by Robert Boyle in the year of 1661. Whereas in the Robert Boyle time, just we know about only 13th element, only 13 elements. In the year of 6061, just we know about only 30 elements. Toward the end of the 18th century, by the time of the Lavoisier, just he discovered another 11 elements. By the 1865, about approximately 63 elements were known. Whereas in the 1940, the total 91 elements. Out of the 91 elements, 17 elements are the synthetically prepared in the laboratory and remaining are the natural. By 2021, as the man-made or the synthetic, approximately we know about 118 elements. As the number of elements increase, it's difficult to keep in a memory. As the number is increased, it's difficult to keep in a memory. That's why the scientists they are trying to do classify the elements. Now we will discuss about one by one classification. Now first classification is Dobenier's law of triode. Triode meaning three elements. Tri meaning three. So first time Dobernier in the year of 1829 is tried to classify the elements. In the year of 1829 he tried to classify the elements, and Dobernier stated that when three elements when the three elements with the similar properties are taken at the time and arranged in the increasing order of their atomic weight. For example, if I am taking lithium, sodium, potassium, just here I am taking lithium, sodium, potassium. Lithium, sodium, potassium are the similar properties containing elements. Why? Because all those are the bases. So similar properties containing elements, they are taking into the one set of triode, and he said that first element atomic weight and third element atomic weight by average is the middle of the element. First element atomic weight and third element atomic weight by the average is the middle of the element. For example, lithium, sodium and potassium. Lithium atomic weight is the 7 and the potassium atomic weight is the 39. So 7 plus 39 divided by 2, that is equal to 23. That 23 is the atomic weight of the sodium. Along with that, calcium, strontium, barium. It is also another set of triode, and the calcium atomic weight is the 40 and barium atomic weight is the 137, and by the average is 40 plus 137 by 2, that is equal to 88.5 and 88.5. And along with that, chlorine, bromine and iodine. Chlorine, bromine and iodine. And chlorine atomic weight is 35.5 and iodine atomic weight is 127. So 35.5 plus 127 and divided by 2 approximately 81.25. So the bromine atomic weight is the 81.25. The bromine atomic weight is the 81.25. So this is about the Dobernier law of triode. Just is taking three similar properties containing elements into one set of triode. He arranged that element into increasing order of their atomic weights. But what is the limitation? Limitation of Dobernier's law of triode. And here all the known elements at the time could not be arranged in the triode. For example, in that time something element is known, but all the elements, the theory is not applicable. The law of failure for very low mass containing elements along with that very high mass containing element. So the theory is applicable only some set of elements like lithium, sodium, potassium, like that. Even if I am taking fluorine, chlorine, bromine, actually the fluorine, chlorine, bromine are the one set. But if you are taking the fluorine weight, bromine weight, it is not satisfied the chlorine weight. And if you are taking about the carbon, nitrogen, oxygen, carbon atomic weight is the 12, oxygen atomic weight is the 16. So 12 plus 16 divided by 2, that equal to the 14. But here the carbon is the different properties containing element and nitrogen different property and oxygen different property. So this theory is the failure due to it is applicable to only some set of elements. This is about the limitations of Dobernier's law of triode. Next classification is Newland's law of octave. Oct meaning 8 elements. Oct meaning it is the 8. And Newland in the year of 1865, he tried to classify the elements. And he tried to classify the element in the year of 1865. And just he arranged in the era of 1865, he tried to give the classification of element, and that is popular as the Newland law of octave. Here the Newland also he arranged the elements into increasing order of their atomic weight, and here also the Newland follow the elements into atomic weight concept, and the Newland is arranged into elements into increasing order of their atomic weight, and just is divide the elements into like a 7 columns. Is divide the elements into 7 columns like that. And what he said is the first element and 8th element is having similar chemical properties, and Newland is taking entire elements into 7 columns like a 7 groups or whatever may be, like a lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. If I am starting from the lithium and the sodium is having similar chemical properties. Along with that sodium, if you are counting from the sodium is the 1 and magnesium is the 2, 3, 4, 5, 6, 7, 8th element. Again it is have the similar chemical properties. So this theory is popular as the Newland law of octave. For example, beryllium 8th element is the magnesium. So the beryllium and the magnesium is having similar chemical properties. Along with that, magnesium and calcium is having the similar chemical properties. Why? Because magnesium after 8th element is the calcium. So this theory is just is try to classify the element into one of the order, but drawback is here this theory is applicable only atomic number 20, that is a calcium, and in that time approximately they know about 56 elements he arranged the elements, only 56 elements into groups. He didn't leave any gaps for the newly discovered element. The main limitation is he didn't leave any gap for the newly discovered element. Once you can look at here, and here they didn't have the helium, and here they didn't have the neon and argon. In that time they don't know about, they didn't discover the helium, neon, argon like noble gases. So it didn't leave any gap. So this theory is mainly applicable only atomic number 20, that is the calcium. So more atomic weight number concept containing elements, this theory is not applicable. One of the drawback is here, in the time containing senior scientists, they are not accepted the Newland law of octave. This is about the Newland's law of octave. Thank you students. Keep watch my videos and subscribe my channel. Thank you.